So this is 3.5 compound Boolean expressions. And we actually, I think it was either Ryan or Chris or one of you guys mentioned this last week. Someone said, you know, we could just create a compound expression here rather than writing an extra 2 lines of code, which was very true. But we hadn't really gotten to that yet. So I didn't want to confuse anyone that this is their first time. Maybe they're seeing this. So it says 3.51 and, or, and not. And notice the symbols next to it. The double ampersand, I believe that's called an ampersand, right? Double ampersand, right? Or is, some people call it a bar, some people call it a pipe, right? And it's just a straight up and down line, vertical line. And the not, which is just an exclamation point. Okay, we've already talked a little bit about not. It says, what if you want 2 things to be true before the body of the conditional is executed? And you would use the double ampersand for and in order to join the 2 Boolean expressions. So our lines of code will only execute if both conditions are true. Okay, so if you look in the code example below, it says, what if you want to go out and your parents say you can go out if you clean your room and do your homework? When I was in high school and college, my room was always a disaster. Right? My clothes were everywhere. And I got older and I realized that like I just can't keep functioning like that. I need things to be clean and organized. It says run your code and try different values for cleaned room and did homework. And see what they have to be for it to print you can go out. All right, so we have our class, we have our main method. And then we have a Boolean variable called cleaned room, and it's assigned the value true. And then we have did homework, it's assigned the value false. So it says if cleaned room, basically, is it true? And did homework is true. Then it prints out you can go out. Else, anything else, say you cannot go out. So if I were to run this, it looks like right here, so cleaned room is true, but did homework is false. They didn't do your homework yet. So you can't go out. It'll say, no, you can't get out. Let's run it just to make sure here. And we run it and it says, no, you can't go out. All right. So if I were to backspace this and just type in true, the value of did homework is now true. We were to save this. It says you can go out, right? If clean room was false, it wouldn't have gone to this expression. So let me just walk through this. It evaluated this and said, if, all right, is clean room true and did homework is true? If so, then do this. If one of them wasn't true, if just one wasn't true, then it printed this out. So when a value is false, if one of those is false, it's going to go ahead and run the else. But it needs both of them to be true in order to say you can go out. Okay. We passed, got both correct. Okay. It says, what if it's okay if only one of 2 things is true? And it says, use the double bar as a logical or to join 2 Boolean expressions. So if you want one of them, if only one is true, then it's okay. So it says, for example, your parents might say to you that you can go out for a walk or they don't need the car. Try different values for walking and car is available. Okay, so might say you can go out if you can walk or they don't need the car. So there's 2 different possibilities that you can go out. You can either go out if you want to walk all the way there or if the car is available. So you're finally able to get out and you think, all right, well, I'm not going to walk. I'm not going to walk that far and the car isn't available, then I'm not going out. But let's say the car is available right? If you're going to walk like 9 miles, like you could do that, but you might not want to, right? If the car is available, right? Well, I guess what I'll do is before I change this, let me just go back. If both of these are false, then it says, no, you can't go out. But if only one of them is true, then it says you can go out. I'm gonna tell you a quick story, a real life experience that I had involving a programmer's huge mistake behind the scenes. So I was on Facebook and one of my buddies posted online and said, hey, it was around Christmas time. I said, hey, I was just on Toys R Us's website and I went to check out and I used a coupon code and it was like 50% off. And then I found another coupon code for 25% off and let me use that. And then I went back to use the same coupon code all over again. And it let me continue to use that same coupon code repeatedly until I got my couple $100 order down to like $5. So 50% off, and then 50% off that, 50% off that, 50% off that, 50% off that, over and over and over again. Okay. Where I realized that and I said, let me try, right? I'm going to go online and try. So I went online and I ended up buying my children's Christmas presents, a couple $100 worth of Christmas presents for $10. And I then got an email from Toys R Us. So then, okay, here's the thing. But then I posted on Facebook to all my friends and followers. I posted, hey, go to this. And everyone's commenting, thanks so much. I just bought all this stuff, whatever. And then I checked my email and it was from Toys R Us. And it said, sorry, your order has been canceled. So I called up Toys R Us and I talked on the phone for like 45 minutes. And I said, hey, you should be thanking me that I identified this error in your system, right? So really, someone behind the scenes definitely either got fired or got in pretty big trouble because when they programmed it, instead of programming or you can use this coupon code or this one, they wrote and, right? So who knows what they wrote it in? Maybe it was in JavaScript, right? But yeah, it was pretty bad. But they gave it to me. They processed my order and I got all my kids' Christmas presents that year for only $10. It was nice. So just a cautionary tale, right? If you're ever in a job, this matters. Please consider the difference between and or, all right? So just we're talking about and or. So it makes sense to talk about that. All right. Just in English, we often use an exclusive or, like in the sentence, do you want to be player one or player two? Where you can't be both player one and player two. In programming, the or operator is an inclusive or, which means that the whole expression is true if either one or the other or both conditions are true. So, you know, if in that case, if I go back right here, if I would like to walk and the car is available, of course I can go out, right? But only one needs to be true. It says with numeric values, the or operator is often used to check for error conditions on different ends of the number line. So if you go under a certain score or over a certain score, right? And this, it shows that, like, let's say grades come out, you shouldn't really have a grade over 100. Even if your teacher gives you extra credit at the very end of the school year, your grade will be rounded down to a 100. That's the most that you can get. I don't know how you can get a negative grade. If you do that, that'd be interesting. But I've never seen someone get a negative. I mean, I have had students receive like a 3% in my class before, but I think that's the lowest, a 3%. And they just didn't do anything, right? They did half or answered 2 questions of a 10-question assignment and then didn't do anything the rest of the year. And then I had to ground their grade up to a 65 because that was the lowest grade that we were allowed to give, 55. You can't give lower than a 55. So with that, let's look at this. So it says explore and or, and see how they're used with numbers. So here's our main method. We have an int called score, and it says try what happens when it's -10 and 110. Let's just run and see what happens when it's 10. It says score is in the range between 0 to 100. All right, let's try -10. Not sure how you get a negative score. Maybe you forgot to write your name on it, right? Maybe your teacher was mean. All right, and then let's try 110. And it says score has an illegal value. So then you could like even write something in there, you know, if the score has an illegal value, all right, then print out, or then change score to 100, right? If score is greater than 100, then change score to 100. But that wouldn't work for this one because it also uses if it's under 0. Then you have the not operator, which is just the exclamation point. It can be used to negate a Boolean value. And we've already used this. I think they just, I mean, we talked about it earlier. I know we've used it before. Okay, so you can say if homework is not done, that's what that exclamation point out in front means. If the homework's not done, then say, sorry, you can't go out. Okay, so if I were to run this, it says, sorry, you can't go out. But if you end up saying homework done is true, it runs and nothing prints out, right? There's no else. So something, I mean, it gives you the value true here, but there has to be some sort of check to see if you did your homework. Maybe you'd input in a program whether you did your homework or not. But this condition, you would think if whether something is true or false, and then have something happen. Okay, in Java, this is important. It says the exclamation point will be executed before and will be executed before or. So that's kind of the order of operations, if you will. And if you want to go in a different order, then put things inside parentheses. I always like using parentheses. Right? I'm not going to rely on the computer to order it properly. I don't trust it. Even when I'm using a calculator, just to make sure I'm always using parentheses where they're supposed to be and not assuming the calculator is going to do one thing. I don't know. So get in the habit of using parentheses, but at the same time, this is the order of operations. You would have the not, you would have the and then the or. Oh, truth tables. I took, when I was in college, and part of my major, you had to take philosophy 104, which was logic. We did a lot of truth tables, and I really enjoyed the class. Okay. It says the following table is called a truth table. And some of you guys may have used these before. It says it shows the result for P and Q when P and Q are both expressions. So it's basically saying, if you're looking at this truth table below, if P is true and Q is true, if you're looking at the condition P and Q, then that also must be true. All right. If P is false and Q is true, then the answer would be false. If P is true and Q is false, P and Q has a question mark there, right? And then it says, if it's false and false, the answer would be false. So let's look through this. It says the truth table above is missing one result. Okay, what would happen if one is true and one is false? Then P and Q is going to be false. All right, so it goes through all possible conditions in the truth table. Okay. I don't know if you guys forget if you guys go through this at all in like physics when you start talking about, or maybe it's even in calculus. Yeah. So you're going through like inverse and contrapositive. I know you go through it in geometry a little bit, but going through different conditions. It says the following table shows the result of P or Q, right? So if P is true and Q is true, then of course P or Q is true. Okay, we're looking for P or Q. Well, P is false and Q is true. There's a question mark there. If one is true here, then the P or Q must be true. If they're both false, then it would be false. So the answer here for this question mark, one of them is true. Q is true, which means that P or Q must be true as well. So if I type in true there, it says correct. All right. So that's all it is. You know, these truth tables, it could be a lot more complicated than this, but this is an example of a truth table if you've never seen one before. Many of you probably have. All right, it says 357. What is printed when the following code executes and X has been set to 3 and Y has been set to 9? Okay, so it says if X is greater than 0, what was X? 3. So that's true. And then it says, and this condition must be true as well. Y divided by X, 9 divided by 3 is equal to 3. That's true. Then first case should print, else second case. So first case should be the answer. Let's check it. Okay, it's right. 358 says, what is printed when the following code executes and X has been set to 3 and Y has been set to 6? All right, X has been set to 3. Okay, so 3 is greater than 0. And so this condition must be true as well for this first condition to run. It says Y was 6. So 6 divided by 3 equals 2. And 2 is not equal to 3. And since 2 is not equal to 3, then both of these conditions, this is a true false. Okay. In order for this to run, it needs to be a true true. So this does not run. So it moves on down to the else and it prints out second case. Let's go ahead and check it. And that's right. All right. 359. Another example. What is printed when the following code executes and X has been set to 3 and Y has been set to 6? Okay. So it says if X is greater than 0. Okay. So 3, X has been set to 3. I don't even need to look at what the second part of this is because 3 is greater than 0. This says or. This is already true. This is going to run. Okay. But then you have an or. 6 divided by 3 is equal to 3. That's not true. So I have a true false. But just because I'm using an or here, this or is going to run just because one of the conditions is true. This is true. So this is going to run here. All right. So it should say first case. And that's the answer. All right. 353 short circuit evaluation. It says both and or use short circuit evaluation. That means that the second expression on the right of the operator isn't always necessarily checked. If the result from the first expression is enough to tell if the compound Boolean expression is true or false. So just like we said in this last example right here, it notices that that's true. So it's going to, quote, short circuit and it's not going to waste time to even go past this because it says if it's true. Okay. Or I don't even need to look at that. So I'm just going to go ahead and do that. It saves time. Okay. The short circuit evaluation. So if two Boolean values or expressions are combined with a logical or, and the first expression is true, just like in the very last example we just did and I just showed you, then the second expression won't even be executed. Okay, since only one needs to be true. And if two Boolean values or expressions are combined with a logical and the first expression is false, it won't even bother going to the second one because it knows that both need to be true. All right, so let's take a look. What is printed when the following code executes? X is set to 0 and Y is 3. Okay. It says X is 0. 0 is greater than 0. Is that true? No, it's not true. So since it's false and this is an and, it's not even going any further. And I'm not even going to go any further. I got a false. So I'm going to go down here and run the else. So it says you will get an error because you can't divide by 0. In this example right here, in the second half that I skipped, right, and the compiler skipped as well, it said y, which was 3, divided by 0. You can't divide by 0, but it never even looked there. It short-circuited out and went right to the second case. So this is a bit of a trick question. And this is like always on the AP exam, right? This is a really good trick question. Okay, what is printed when the following code executes and X has been set to 0 and Y is set to 3? All right, so X is set to 0. It says if 0 is equal to 0, well, that's true. The first case is true. So it will short circuit out and move to the first case. It doesn't matter that when you divide by 0, as I mentioned in the last example, it doesn't even take that consideration, right? This is true, so I run this. Okay, so it says 354 programming challenge, truth tables. And it's process-oriented guided inquiry learning. You don't need to do that, but you don't need to work in teams. This says explore the following problems with your group. Draw a Venn diagram. Let me see the actual part down here. All right, so it says draw or print a Venn diagram of 4 intersecting circles. Put the names of the 4 people in your group, 1 in each circle. Write down the age of each person in your groups, blah, blah, blah. Let's see here. Here we go. Write the sentence, if it's sunny, or if the temperature is greater than 80 and it's not raining, I will go to the beach, as a Java statement using an int variable temperature and Boolean variables sunny and raining. If the conditional is true, print go to the beach. Okay. So you will go to the beach on days that is sunny in any temperature, or you will go to the beach on days when the temperature is over 80 degrees and not raining. It's saying complete a truth table. We're not going to actually create that truth table. It says write Java code below to test your if statement. All right. So let me just zoom out briefly here. Let me see what we have here. So these are the variables, sunny, temperature, and raining. Okay, so I have temperature, sunny, and raining. They already wrote those in there for me. And it says write an if statement for if it's sunny or if temperature is greater than 80 and it's not raining. But then up here it says if the condition is true, print out go to the beach. It says if I will go to the beach if it's sunny or the temperature is greater than 80 and it's not raining. Okay, so if it's sunny, so if sunny or temperature is greater than 80, so if temperature is greater than 80 and it's not raining, so I'll put an exclamation point next to raining. Okay. Then it would print out go to the beach. But let's make sure all of these are actually properly written, right? Because if we don't want to run if sunny and then that be true and then completely disregard everything in there, right? So we want to make sure to include everything properly and not skip over anything. So let me go ahead and write this first. I'll write my system dot out dot println. I'll say go to the beach. Okay. So the question is, do we want to go to the beach just because it's sunny at any temperature? Because if we're looking at this, it says, write the sentence, if it's sunny or the temperature is greater than 80 and it's not raining, I will go to the beach. Okay, so you will go to the beach on days that it is sunny in any temperature, or you go to the beach when it's sunny and it be like 20 degrees outside, right? Or you will go to the beach on days when the temperature is over 80 and not raining. So I'm going to go ahead and use parentheses here. So that way these two are combined together. So let's run this. So if it's sunny in any temperature whatsoever, or the temperature is greater than 80 and it's not raining. Let's see if I made any mistakes. Looks like it works. Okay, so I guess the way they want it to run is even if it's 20 degrees outside and it's sunny, it tells you to go to the beach. It's not a very good advice. But if the temperature is greater than 80 and it's not raining, I honestly wouldn't like to go to the beach if it's 80 degrees. I would only like to go to the beach if it's like 90 something degrees, because when it's 80, it's a little like sometimes you get the breeze coming in and it gets a little chilly. Like I think 80 would be a cold day for a beach. Maybe I'm wrong. 80? You think 80 would be good to go to the beach? Yeah. Okay. I think like anything under 75 is like super cold. Like I always am wearing a jacket. You'll rarely catch me outside without a jacket unless it's like in the dead of summer, like over 90 degrees. God bless you. God bless you. I would think if I were to write this, I would need for it to be sunny. I need the temperature to be over 90 and it not actually, yeah, I guess if it's raining, it wouldn't necessarily be the best. Yeah, so not raining. So I'd rewrite mine. I would write if it's sunny and the temperature is greater than 90 and it's not raining. That would have been mine. All right. So just to summarize, we talked about these logical operators. So we've talked about logical operators. We've talked about mathematical and arithmetic operators. And we've also talked about relational operators, less than, greater than, less than or equal to, greater than or equal to. And that kind of extends the different operators that we're going to end up working with in this class. So if A and B are true, then both A and B are true. Okay, if A or B, then only one has to be true. And if it's not, you can just write an exclamation point, just like we did with if it's not raining. Okay, parentheses can be used to force the order. I always like using parentheses. And then we also talked about short circuit evaluation and how if when the compiler is going through and it recognizes that that the condition has already been set, then it won't necessarily even continue. It will just skip out and not read the rest of what you have in there. All right. 356, there's this game again. It says try clicking on Boolean. Let's see. Okay, so it says true, false, a Boolean game. So it says not green or not 1. So it is green and it is 1. So it's a false, false. So that would report false. Okay. If it's not red, it is red. And so I'm going to short circuit out right there. If it's not green or it's not 2, those are both false. So the answer would be false. If it's gray or 2, so we finally get a true because it is 2. So I get true. All right. So it looks like we have a color as well as a number each time. It's not green and it's not 4, so it's false. All right, so we just are able to start matching the Boolean expression. So we've done the strings one, we've done the relational one, we've done the Boolean one. It says you have attempted 13 out of 13 activities on this page, completed, well done. And that was 3.5 compound Boolean expressions.